All right, in this video, I want to I don't think I really emphasized what finding those 5 key points really does. And I want to look at that again before we start graphing the problems on the worksheet on graphing. Because it is so helpful. And if you really understand what the big deal is, I think you'll have a simpler time doing your graphing. So, when you have y equals sine x or y equals cosine x, right? The period is 2 pi. Okay. All right, so that means you complete a full cycle. From 0 to 2 pi, okay? So one way to think about that is to go back again to that unit circle and to those 5 key points, okay? So pretend that's a good, well-drawn circle. All right, so 0 is your starting point, 2 pi is your ending point. Halfway in between is pi. Halfway in between those two would be pi over 2, and halfway in between these two would be 3 pi over 2. So those are the 5 key points when we're dealing with a basic y equals sine x or cosine x. And in fact, even when we're doing secant or cosecant. Well, those 5 key points correspond to these, okay? So this is your 1, 2, 3, 4, 5, and here's your 1, 2, 3, 4, and then we're back here for the 5th point, okay? So even the language, like when I'm thinking about how these graphs are periodic, how you have a chunk of the graph that just keeps getting copied and pasted both to the right and to the left, that chunk that keeps getting repeated over and over again happens in one full cycle. One revolution around the unit circle is one way to think about it, okay? All right, and then so these angles, 0, pi over 2 pi, 3 pi over 2, and 2 pi, okay? These are the quadrantal angles. So all of those are those quadrantal angles. So it's really easy then to determine the sine, the cosine, and so on. Okay, the 5 key points, the 0, the pi over 2 pi, 3 pi over 2, and 2 pi are the quadrantal angles that you hit as you move around that unit circle, okay? All right, so, if you're doing, say, sine, that's the y coordinate of the ordered pairs, which you can easily label, and you can just go from there, and you see it going from 0 to 1, back to 0, down to -1, back to 0, okay? All right, so when you graph the variations, so when you graph something like y equals sine with maybe some number times x plus or minus a number, or y equals cosine bx minus c. Okay. The starting point and the period are affected. Okay. But what is great is if you can figure out where to begin and where to end, and then you know how to break it up to get those 5 points, then you will wind up knowing what the output would be, because you can just use what you did in the most basic case, the 0, the 1, the 0, the -1, and the 0. Okay. All right, so the way we're going to do that to find those 5 key points is we're going to take that bx minus c and we're going to say, okay, normally the input which in the most basic case is x, whatever's here is your input, has to be between 0 and 2 pi. And so we go and we solve that, only we'll have numbers. We won't be doing this with the variables. We solve it for x. I'm going to go ahead and distribute that b into both. And so we wind up knowing the new starting point, okay, like 0.1, and then this over here is the ending point. So this is our starting point, this is our ending point. The difference between these two is the period. So the period is the 2 pi divided by b, whatever that turns out to be, okay? So we know our starting point, which is going to correspond to that location, our ending point, which corresponds to this, and then we're going to break it up like we did here to find what's halfway between and then what's halfway between each of those, okay? So before I do some actual graphing, I'm going to take just those issues, okay? So I'm going to take some situations that we might be trying to do in the future and see if we can figure out what the 5 key points are going to be. So let's say, and let's not graph, let's just do the 5 key points for a while. So let's say, and we'll do a lot of these. So let's say we're trying to do y equals, and I'm just going to look at the b, the part that's in here with the x. So let's say you're doing something like that. Okay. Or what if you had y equals sine of 2x minus pi? Or what if we had y equals secant of x plus pi over 4? Let's do a couple of these, okay? All right, so the period for cosine, for sine, and even for secant is from 0 to 2 pi. And so we're going to start by thinking about that inequality and solving that. So here I would multiply through by 2. Okay, so if I multiplied through by 2 everywhere, that'd be 0 is less than or equal to x is less than or equal to 4 pi, okay? So when you look at that and look at the difference between these two, you can see that the new period is 4 pi, okay? And so what we're going to do, how we're going to use that, oh, and by the way, there wasn't any kind of a shift. It's still starting at 0. So it's starting at 0 and it's ending at 4 pi. Now here's what I'm trying to practice here that I want you to understand how to do. It helps so much. Okay, so we're going to look first at halfway between that would be 2 pi, and then halfway between this would be pi, and halfway between this would be 3 pi. So that one turned out to be pretty easy because you didn't have any fractions involved. Okay, but here's what I want you to realize has happened. That because our new period is 4 pi and we have those 5 key points, the output we get from those 5 key points is going to be what we would get moving around that unit circle, that circle, even though it's not really just one rotation anymore. Okay, let me see if I can explain that better. See, this interior part is really now 1/2 x. So when you do 1/2 x on each of these, see how you're going to be back to those key points that we had in the basic one? That's what happens. And so the value of the output for these new 5 key points would be the same as what you would get as you move around that unit circle. Okay, so we're thinking cosine. That's a 1, 0. Okay, and we're thinking cosine, which is the x coordinate. So when we come in here to do cosine 1/2 x, Well, that's really going to be 1. And then we're going to go to here. That's going to be 0. Then we're going to move over to pi, and that's going to be -1. And then down here at 0, and then back around at 1. Okay? But what we actually graph on our coordinate plane are the x's with the cosine 1/2 x. But you see how those 5 key points had the same values here that we get when we do the basic cosine graph. Okay, so if you find your new starting point, your new ending point, and you break it up into those 5 key points, the value you're going to get over here will be the same as what would happen if you moved around that unit circle. Okay. All right, let's try another one. All right, this one is 2x minus pi in here as the input. So we're going to put that in between 0 and 2 pi, and we're going to solve that. That's going to be your first step. So you're going to add pi, and you're going to add pi over here. Then you're going to divide by 2 everywhere. Okay, so your new starting point is pi over 2. It used to be 0. Your new ending point is 3 pi over 2. Okay. So your x value is, for your 5 key points, would start with pi over 2 and end with 3 pi over 2. Okay. All right, now the period, the new period actually is the difference between these two. And see, 3 pi over 2 minus pi over 2 is 2 pi over 2. The new period is really pi. Okay, but I don't need that as much as needing the starting and ending, the beginning and end of those 5 key points. Okay, now looking at a graph can help you get the in-betweens, or just getting some practice with fractions can help you as well. Okay, so I'm going to maybe do it over here a little bit, or maybe I'll have room on this side. So to find this middle spot, the easiest thing would be to look at the graph. Okay, so let's do that. Let me go back up or back down. Let's see where it is. Okay, so we're trying to find, here's the starting point, okay, and here's the ending point, and we're trying to get 5 key points. So you can do it visually sometimes. So halfway would be pi, and then half of that and half of that you need to figure out. So you should be able to see that this is pi pretty easily, or you can actually find the midpoint. Take pi over 2 plus 3 pi over 2 and cut it in half. That would be 4 pi over 2, and 4 pi over 2 is 2 pi, and 2 pi divided by 2 is pi. If you can avoid that by looking at the graph, then do that. That's what I would look at the graph. So we're going to start at pi over 2, end at 3 pi over 2, so the halfway spot would be pi. All right, now I need to get the in-between on pi and pi over 2. So again, if you can look at it to find it. So, if you cut this and put in an extra little spot right there, can you imagine that? That's cutting pi into 1, 2, 3, 4 places. You can think about it in the coordinate plane, or you can think about it, if it's easier for you to think about, on here. If you're trying to get, so you got the halfway between pi over 2 and 3 pi over 2, and see how that was pi. And then you need the halfway between this and this. So sometimes just looking at the unit circle or looking at the coordinate graph, okay, I can find those locations. So see, I can tell that if I could split this, let me make it bigger. Let me erase this part. And so sometimes just looking at that unit circle very carefully, where I want it. Okay. All right, so think about it on the unit circle. All right, so your starting point is at pi over 2, your ending point is at 3 pi over 2. Do you see why pi would be this middle spot? And then if I needed the halfway between those, see how that's basically cutting pi into 4 spots? So this would be 1 pi over 2, 2 pi over 2. Let me say it again. That would be 1 pi over 4, 2 pi over 4, 3 pi over 4. So this would be 3 pi over 4. So I can do it by thinking about it on the unit circle or thinking about it on the coordinate graph. Pi is the same as 4 pi over 4, and then this would be 5 pi over 4. But of course, you could look at your unit circle, completed unit circle, to help you, okay? All right, now sometimes it's not so easy. We don't get things that wind up hitting at set values, and you got a little more thinking and algebra to do. Let me just show you on one of these. So if you're trying to find the halfway spot between two things, that's finding the midpoint. So you could take the pi plus the 3 pi over 2 and cut it in half, okay? To be able to add those two things, you need common denominators. So you're going to multiply by 2, top and bottom on pi. So that would be 2 pi plus 3 pi. So that's going to be 5 pi over 2. But then you're dividing by 2. And 5 pi over 2 divided by 2 is the same as 5 pi over 2 times 1/2. This kind of thing is so much easier when I have a chance to have some face-to-face interaction with you all. Okay, and I just wish you could join me for some of the virtual class sessions. It's just so much easier to explain and to make sure that you're understanding as I go through it. So try to budget some time to come to some virtual class-to-class sessions. So that's kind of the algebra you can do to figure out these if it's you're not able to do it from the unit circle easily. Okay, now here's why we want to do it. Okay, once we find them, those are the 5 key points it takes to complete one full cycle. Okay, so your starting point, think about your usual starting point. Okay, these are the usual 5 key points. So it's going to wind up being that, and was I doing sine or cosine? Sine. We were doing sine. So I can go back to thinking about, even though that's not pi over 2. I don't want to look at pi over 2 for real. Okay. I want to look at this being the starting point now for me doing a full rotation. So the sine should be 0. Okay. And then for the next key point, that's where 1 happens. For the next key point, that's where I'm back to 0. For the next one, I'm at -1. And for the next one, I'm back at 0. So that's what should happen. Okay. Now, the reason it turns out that way is because the input is really 2x minus pi. So once you take pi over 2 and you multiply it by 2, you'd get pi, and pi minus pi is 0. And the sign of that would be 0. Okay. And then a similar thing here. When you do 2 times 3 pi over 4, you get 3 pi over 2. Subtracting pi, you would get pi over 2. Okay, and then 2 pi minus pi would be pi. And then 5 pi over 4 times 2 would be 5 pi over 2. Take away 2 pi over 2, and see how we're getting back to those quadrantal angles. And then this one would be back at 2 pi. Okay, so what it is that if you find the 5 key points, you're finding the 5 spots on this new modified graph where you get the same old sine values that you got when you were just doing sine x. So that's what the 5 key points do for you. Okay, if you get in the habit of being able to find those. Okay, all right, when we're doing this one, we would start with the secant plus pi, or doing secant of x plus pi over 4. We would take the x plus pi over 4. Secant is related to cosine. It has the same period, so we could still do the 0 to 2 pi. I will erase that, though, because you actually have asymptotes at the ends of that one. All right, and now we're going to solve. So we're going to subtract pi over 4, which will give us a negative pi over 4 on the left. And on the right, we got some work to do. Okay. And so I'm going to multiply by 4 top and bottom, so I get a common denominator. So that's 8 pi over 4, okay, minus pi over 4. So that'll be 7 pi over 4 on that side, and a negative pi over 4 on this side. Okay. Now, if you look at the difference between these two, or if you look at that portion right there, okay, that's the new period. So the period didn't really change. 7 pi over 4 minus negative pi over 4. So minus a negative. I wind up getting 8 pi over 4, or 2 pi. So that's the period still. But you see how the beginning point is now different? Okay, that's a phase shift. Okay, same thing or a similar thing happened on the previous one. Okay, this one had both, this middle question had both a different period and it had a different starting point. That right there is your phase shift. It's going to start over, it's going to slide over pi over 2. This one's going to slide back to negative pi over 4. Okay. So when we get around to graphing this, we usually actually graph the cosine, and then we go in and do the secant. But I want to get those 5 key points on here. So your starting point, and there's your ending point. Now see, this is going to be a little bit harder to visualize. Okay. So you can do the unit circle if you want. So here's negative pi over 4 is here. 7 pi over 4, okay? So if you do this, the negative pi over 4 would be here, okay? And then 7 pi over 4, well, that would be 1, 2, 3, 4, 5, 6, 7. So it would be one full rotation. Do you see that? Okay, so it would be one full rotation. You'd be back at 7 pi over 4 here. So halfway is going to be right there, okay? So if you can see that, you just need to count what that is. So that's going to be 1, 2, 3 pi over 4 will be halfway. Sometimes you can see better by looking at where is negative pi over 4 on this, and then thinking about pi being cut into 4 pieces. So that would be negative pi over 4. This would be 1, 2, 3, 4, 5, 6, 7. 7 pi over 4 would be right here. Okay, this would be negative pi over 4. So the halfway spot, see how you have 1, 2, 3, 4, 5, 6, 7, 8 spaces? Halfway spot would be 1, 2, 3, 4, would be right there. And then you need to be able to interpret what that is. So this is 1 pi over 4, 2 pi over 4. This would be 3 pi over 4. Okay, if you're more comfortable doing your algebra, you can just get the midpoint. Add those two together and divide by 2. So a negative 1 plus 7 would be 6 pi over 4. When I divide by 2, that's 6 pi over 8, and that reduces to be 3 pi over 4. If you can get to where you can find these 5 key points, it really simplifies things. All right, so let's now think about this. Let me do it in blue. This right here was the halfway spot. Okay. All right, so if we need half of that, I think you can tell what that's going to be. Halfway between these two would be pi over 4. And then halfway on the other side would be here, and that would be 5 pi over 4. Okay. Again, you can calculate it by doing the midpoint, doing 3 pi over 4 plus 7 pi over 4, and divide by 2. See how that would be 10 pi over 4. And when you divide by 2, that's going to give you 10 pi over 8, and that would reduce to be 5 pi over 4. Okay. You can do a similar thing for pi over 4. You also, if you prefer looking at the coordinate graph, you could think about, you can see where you need to be. You need to be right there and right there. And so you could look at that and try to calculate it. Okay. So if this is 3 and this is 7, this looks like 5. Okay, so that's 7, 6, 5 pi over 4. Okay. All right, this would be 4 pi over 4, 3 pi over 4, 2 pi over 4. This would be 1 pi over 4. Okay, so sometimes you can get it that way. All right, now here's why we want to get it. All right, I normally do cosine before I do secant. And so I can think about my points, and I'm not looking at negative pi over 4 on the unit circle. I know that ultimately, once I plug in the x plus pi over 4 right here, once I put that into the x plus pi over 4, I'm going to get back to 0, to pi over 2, to pi, to 3 pi over 2, and to 2 pi. And so if I'm trying to do, say, cosine initially, maybe I'm trying to do cosine. Oops. All right, so if I'm trying to do cosine first before I do my secant, then I know, well, cosine of 0, well, that's 1. Cosine of this is 0. Cosine of pi is negative 1. Cosine of that is back to 0, and cosine of that is back to 1. What I'm actually going to graph will be these two, and then I'll worry about making it a secant graph when I'm finished. Okay, so working on being able to do those 5 key points and understanding how then we get the usual output values as you go around the unit circle, that's why we do it, can be helpful. Okay, the same idea can work for tangent and for cotangent. I won't do much with that. Okay, I won't do much with that. I just want to mention it. It's just with tangent. Okay, you're doing from negative pi over 2 to pi over 2, remember. And with cotangent, that would be from 0 to pi. That's when you make your inequality, okay? Whatever you're adjusting would go there, okay? So if you're doing like tangent of x minus pi over 4, that x minus pi over 4 would go in here. And if you're, say, doing cotangent of 3x or something like that, then the 3x would go in here. Okay, you have a different starting and ending point because the period on these two is really just pi. Okay. All right, that's probably gotten kind of long. I'm going to go ahead and maybe stop that, and then I'm going to do a video looking at the worksheet for 5.5 and 5.6.